All right, so yesterday's problem of the day said two cars are in a race starting from rest. The red car accelerates at 10 meters per second squared and finishes in 12 seconds. The blue car accelerates at 8 meters per second squared. And we want to know how far behind is the blue car when the race is over. All right, so this one's a little trickier because we got two cars here to deal with today. But we can still figure out our givens and our unknown. We just have to be careful about which of the cars we're talking about. So can somebody start and tell us one thing that is given to us in this problem?
So we got the initial velocity for both car.
Yeah, the initial velocity, the initial velocity for both cars is the same, right? What's that going to be?
It's gonna be 0.
Yeah, so they both have a initial velocity of 0. Okay, good. Thanks, Jose. And what else do we have for a given? Let's look at the red car first. What are the givens regarding the red car? All right, I see somebody.
We got 10 meters per second square.
Yeah, and what is that quantity, right? We want to know not just what the number is, but also
acceleration.
That's acceleration, right? Thank you. So acceleration for the red car is 10 meters per second squared. What else do we have for the red car?
How fast it finishes.
How fast it finishes, right? So what's that? What quantity is that?
VXF.
Well, it's because you don't really say how fast it finishes, right? It's how long it takes to finish. Right?
Oh yeah, so time.
So time, good. So 12 seconds would be the time. Okay. Good. So for the red car, we have an initial velocity, we have an acceleration, and we have a time. So we should be able to figure out the red car. The blue car, we know it starts as rest as well. What givens do we have for the blue car?
The acceleration.
Which is
8 meters per second.
Right, 8 meters per second squared for the blue car. And it doesn't say, but let's see what else. We do know something else, right? What's the last given for the blue?
I think we got the same time, 12 seconds.
Yeah, it's the same amount of time, right? The race lasts until somebody finishes, and the race is over in 12 seconds. So the race is really over in 12 seconds for both. So we'll put 12 seconds there for the blue car as well, because we want to know how far it's going to go in that 12 seconds. Okay, so we've got 3 givens for each of those cars, and we need the unknown, right? What are we actually looking for? What quantity are we looking for each?
For the distance.
The distance, right? If we want to know how far behind the blue car is, we have to know how far they each go. Right? So we'll have to find the distance that each of them go. And if we can do that, then we can see how far the blue car is behind. Okay, so what we've got is givens and unknowns for each of the 2 cars, the red car and the blue car. We want to find delta x for each of them. And since they both have the same symbols, right? We're looking for VXI, AX, delta t, and delta x. It's going to be the same equation for each of them, and it's going to be rearranged the same for each of them. We just need to pick out which equation to use. So does anybody see which equation I want to use if I have the symbols VXI, AX, delta t, and delta x?
The third one.
The third one, right? This third equation is the only one that has those 4 symbols, right? VXI, AX, delta t, and delta x. And it's nice because we don't have to rearrange it either. And we'll need to do it twice, right? So I'll do once for the red car. Delta x is the VXI times delta t plus 1/2 AX times delta t squared. And I'll plug in my numbers for the red car, and then I'll do the same thing for the blue car. Right, we know it starts at rest, so the VXI times delta T is still going to be 0. And then I do plus 1/2 times, for the red car was 10 meters per second squared, times 12 seconds, and I have to square that. So it looks like the red car gets to travel 0.5 times 10 times 12 squared is 720 meters. So delta X for the red car equals 720 meters. Okay, questions about that so far? How we got the red car? So we use the same equation for the blue car, right? Because we have the same list of symbols, rearranged the same way. All right, and we just plug in different numbers. The VXI for the blue car is still 0, so that first piece still goes to 0. Anything times time, or 0 times anything is 0. Plus this time we do 1/2 times the blue acceleration, which is only 8 meters per second squared, times the 12 seconds. And square that. So for the blue car, 0.5 times 8 times 12 times 12 squared is 576. So how far the blue car goes is 576 meters. So we're almost at our answer, right? We figured out how far each of those cars went. What's the last thing I need to do? If I go back, remember the question, take one more look at the question. It's asked how far behind is the blue car when the race is over? So what do I need to do to get that final answer if I want to know how far behind?
We need to subtract the 720 minus 576.
Yeah, perfect. Right. So the difference is how far ahead the red car is going to be. So the blue car is going to be 720 meters minus 576 meters behind. So if I do 720 minus 576, that's 144. All right, so that's how far back the blue car would be when the red car finishes the race. All right, it's a little bit trickier than the ones we've been doing, but only because you just have to do it twice, right? Once for the red and once for the blue. If you can kind of keep those two separate. All right.